Welcome. In this video, I'm going to torture everyone a little bit and use the limit definition of the partial derivative to calculate the partial derivative of this function f with respect to x and the partial derivative of this function f with respect to y. And I think I'm mostly torturing my calculus students who don't want to do this, but we're going to get through this and then I'll show you the easy method. Okay, so let's recall that the partial of f with respect to x is equal to the limit as h approaches 0 of f of x plus h, comma y, minus f of x, comma y, over h. So this is really, really similar to the limit definition of the derivative for a function of one variable. And all of you watching this should hopefully already be familiar with that. Now, the partial of f with respect to y, well, that's equal to the limit as k approaches 0 of f of x comma y plus k minus f of x comma y over k. All right, so let's begin with the partial of f with respect to x. This is equal to the limit as h approaches 0 of 4x plus h squared plus 2x plus hy minus y squared plus 3x plus h minus 2y plus 5. That takes care of just this portion. Now, rather than doing minus and writing everything in a parenthesis, I'm just going to distribute this negative sign as I go and just change the sign of everything. So this is minus 4x squared minus 2xy plus y squared minus 3x plus 2y minus 5. And this entire quantity is divided by, or the entire expression actually is divided by h. Now bear with me while I rearrange the screen just a little bit. So let's distribute what we can, and remember that this is x squared plus 2xh plus h squared. So we have the limit as h approaches 0 of 4x squared plus 8xh plus 4h squared plus 2xy plus 2hy. So I'm here now distributing both the 2 and the y to each term, minus y squared plus 3x plus 3h minus 2y plus 5 minus 4x squared minus 2xy plus y squared minus 3x plus 2y minus 5. Hopefully I didn't miss anything. And this entire expression again divided by h. Now I can cross out anything, any like terms that have opposite signs. And right away I see a negative y squared and a positive y squared. I see a negative 2y and a positive 2y, positive 5 and a negative 5, 4x squared and a negative 4x squared. Let's see, positive 2xy minus 2xy, and I think we are almost done. A positive 3x and a negative 3x, and that looks to be it. And if I missed anything, I'll catch it on this next step. Those of you in my class, notice how I'm writing everything down, the limit notation, every term here that I didn't change at all, I just wrote it down again on every step. So those of you in my class, I do expect to see this detail of work, at least on your first couple assignments, and certainly on exams. So this is the limit as h approaches 0 of 8xh plus 4h squared plus 2hy plus 3h. And let me double check that that's it. This one, this term, and the rest look to have been crossed out. This whole thing divided by h. So this is the limit as h approaches 0 of h times 8x plus 4h plus 2y plus 3, all divided by h. This is very nice because h divided by h is 1. And let's continue this here. This is the limit as h approaches 0 of 8x plus 4h plus 2y plus 3. So this is 8x plus 4 times 0 plus 2y plus 3. Here I directly substituted the 0 in for h because it is in the domain of this multivariable function. And that tells me that the partial of f with respect to x is equal to 8x plus 2y plus 3. All right, I'm going to go ahead and clear this away and make space for the partial of f with respect to y. Those of you working independently, just continue on whatever space of paper you have, or use scratch paper if you are out of paper within your guided notes template. All right, let's continue. The partial of f with respect to y is equal to the limit as h approaches 0, k approaches 0. We're using this one now. And since it's the partial with respect to y, you notice the k is, or that is, the k corresponds to the y variable. So this is 4x squared plus 2x times y plus k minus y plus k squared plus 3x minus 2y plus k plus 5. Then we subtract 4x squared minus 2xy plus y squared minus 3x plus 2y minus 5. And this entire expression divided by k. I'm going to do the same thing where I'm going to rewrite and distribute all in one step. So this is equal to the limit as k approaches 0 of 4x squared plus 2xy plus 2xk. I just finished distributing this portion here. Minus y squared minus 2yk minus k squared. I multiplied out y plus k squared, then distributed this negative. Plus 3x minus 2y minus 2k plus 5 minus 4x squared minus 2xy plus y squared minus 3x plus 2y minus 5, and this very long expression completely divided by k. All right, this is the limit as k approaches 0. Now, before I write anything down, I'm going to go ahead and see what adds up to 0. 4x squared minus 4x squared is 0. Positive 2xy minus 2xy is 0. Negative y squared plus y squared is also 0. 3x minus 3x is 0. Negative 2y plus 2y is 0. And then finally, 5 minus 5 is 0. And if I didn't miss anything, it'll come out in the next step. So what we have left is 2xk minus 2yk minus k squared minus 2k. And this entire quantity divided by k. Now I can go ahead and factor out the like term in the numerator. Another reminder for those of you in my course, I do expect you to show all this type of work, especially on your exams, unless I'm telling you to use the easier method. Right now we're still using the limit definition, but we won't always do that. So this is k times 2x minus 2y minus k minus 2 divided by k. K divided by k is just 1. So we are left with the limit as k approaches 0 of 2x minus 2y minus k minus 2, excuse me, no, divided by 1, so I don't need that fraction symbol. I can go ahead and put in 0 for k without problem. So this is equal to 2x minus 2y minus 0 minus 2. So the partial of f with respect to y is equal to 2x minus 2y minus 2. All right, that's all I have for you in this video. Hopefully you found this useful and I didn't put you to sleep. Please keep calm and math on.